Hello, algebra students, and welcome to the final lesson in topic 6, lesson 6.5 on transformations of exponential functions. So again, we've talked about transformations before when we did linear functions. Now, today we're going to focus just on the shifting or the translations, right? So the shifting. And you'll see as we go through today's lesson, again, shifting up and down, shifting left and right, and how that affects the graph. Okay? All right, cool. All right, so vertical translations. Again, when they say translations, that's the same thing as being a shift, right? So when they say this word translations, that also means a shift. Okay. So it says, how does the value of k affect the graph of f of x equals 2 to the x plus k? So again, notice that this plus k is at the end. It's not up here with the x. So this is going to be a y translation or a vertical translation. It's going to affect the y, right? So you're thinking up and down, right? Okay, so we have the graph of y equals 2 to the x, or f of x equals to the x right here. So this is f. Okay, so now I'm going to graph g of x and j of x on the same graph, and we're going to see what happens. And I'm going to actually make a table here to show what happens as well. All right, so I'm going to add to this table two more columns. This is going to be the g of x column. So g of x equals 2 to the x plus 3. And this j of x is going to be 2 to the x minus 3. So all that's going to happen is we're going to take our y values, and these are our y values, and we're going to add 3 and subtract 3, right? So when we add 3 to 1/4, we get 3 1/4. Then we get 3 1/2, and we get 4, and we get 5, and we get 7, right? And over here, when we subtract 3, I'll do it in blue. When we subtract 3, we get, and this is a little bit more difficult, but again, I've done it ahead of time. So 1/4 minus 3 is negative 2 3/4. 1/2 minus 3 is negative 2 1/2. 1 minus 3 is negative 2. 2 minus 3 is negative 1. And 4 minus 3 is 1. So again, all the y's are just changing. So these are the y's being added by 3, and these are the y's being subtracted by 3, right? Okay, so let's see what happens, right? So I'll do the red graph first. So the x's are still the same. Oh, sorry. The x's do not change, but now the y's are. So negative 2, 3 1/4. Negative 2, 3 1/4. Negative 1, 3 1/2. 0, 4. 1, 5. And 2, 7. Oh, I'm doing my best here, sorry. So if we graph that exponential function like this, now here's what happens. Notice that this curve, right, 3 1/4, 3 1/2. So if we kept going to the left, we would keep approaching 3. That means that this is going to be the new asymptote for this function. This has the equation y equals 3, so it also shifts up 3, because for the original function, this asymptote is the x-axis, where y equals 0. Remember, you're approaching 0, but never can be 0. So same thing, we shift up 3. So this graph goes as close, but cannot touch. And there's g. So you can see that everything went up 3 units. So that is what happens with this plus 3 at the end. You move up 3. So shifting up 3. Now what about the minus? So again, let's graph the x values and the y values. So negative 2, 2 3/4. I'm sorry, negative 2, negative 2 3/4. Negative 1, negative 2 1/2. 0, negative 2. 1, negative 1. And 2, 1. And again, if I connect these as best I can with an exponential curve, it'll look like this. And then again, the asymptote now shifts down 3. So this, again, negative 2 3/4, negative 2 1/2. It's approaching negative 3. That's your new asymptote, y equals negative 3. And this is, of course, your j. And you can see from the black one, everything shifted down 3 units. Down 3. So that's what the minus 3 does. It goes down 3. Okay, so as a summary answer, I'm going to try to type it right here. So compared to f of x equals 2 to the x, right? When you add that x, so if f of x equals 2 to the x plus k, so with that plus k is shifted or translated vertically. And you go up if it's a positive k, and you go down if it's a negative k. Right? And that's the exact same thing that happened with our linear functions. If it was a plus k at the end, it went up. If it was a negative k, it went down. Okay, so that's our vertical translations. Now we're going to spend a little more time on horizontal ones because they're a little bit different, okay? So it says compare the graph of g of x equals 2 to the x minus h with the graph of f of x equals 2 to the x when h is a positive number greater than 0. What effect does h have on the graph of g? So notice here you have this minus h. So this is the first time we're not dealing with a k. As you get older, the vertical translation of vertical shifting is the k. The horizontal is the h. If you think alphabetically, HK, XY, that's how I think they kind of make it make sense. So this right here is with the x. This is going to be a horizontal shift, right? So it's going to affect the x direction, which is left or right. Right? Now, they have us compare two graphs, and it's already done for us down here. So f of x equals 2 to the x. That's the blue graph here. So this is f of x. And then g of x equals 2 to the x minus 5, and that's the red graph here. Notice that it says minus 5. So you would think that that would mean to the left 5. But remember, if it happens to the x, it's opposite of what you think. So minus 5 actually means you go to the right 5. Notice that this y-intercept at 1 goes 1, 2, 3, 4, 5 to the right. So all the points go to the right 5. Okay? So that's what this minus 5 is going to do. Okay? Now let's go to Desmos, or not Desmos, let's go to Savas and see if this works for, all positive h values. So I'm going to click here to go to Savas. Loading. Here we go. Okay, so yeah, if I scroll down here, so let's let h be 0. So they're on top of each other, yes, right? Because there is no shift. So if h is a positive 1, that's going to say a minus 1 now. Notice you go to the right 1. If h is a positive 2, minus 2, you go to the right 2. Positive 3, minus 3, right 3, 4, 5, and so on, right? So when you have x minus h, right, and it's a minus h value up in that parenthesis, you're actually shifting to the right that many. All right, so in summary, right, let's take a look here. Let's make our summary statement. So our summary statement is going to say compared to f of x, compared to f of x equals 2 to the x, the graph of g of x equals 2 to the x minus h with h greater than 0. Again, when you put a positive h in, it stays a minus h up there. Is shifted or translated horizontally to the right. Horizontally, that's a z, horizontally to the right. So horizontally to the right, h units. And there's our big summary statement. Okay. All right. Part B, let's check out the other horizontal translation. So now part B says, okay, how does your graph compare when your h value is a negative number? Well, if this h is a negative, it's going to be a negative, negative h, which turns into a plus h. So you're going to see a plus number up here, right? So down here, we're going to compare f of x equals 2 to the x, the blue graph, with j of x equals 2 to the x plus 3. Notice when it says plus 3, you would think right 3, but again, it's opposite in terms of the x. So notice for this function j, notice that the y-intercept here at 1 went to the left. 1, 2, 3. When it goes to the left 3, that's because of the plus 3 up with the exponent. Okay, let's go explore this as well on Savas. So again, if I scroll down, let's make it 0. Part B, sorry. Part B, here we go. Okay, so again, let's make it 0. All right, so we're exactly the same. As your h becomes a negative number, remember that would make it this a plus 1. Plus 1 goes to the left 1. H is a negative 2, that would become a plus 2 up there, goes left 2. Left 3, left 4, left 5, and so on. Okay, so in summary, right, compared to f of x equals 2 to the x, the graph of j of x equals 2 to the x minus h, with h less than 0, which essentially means j of x equals 2 to the x, it's going to say a plus h, right? Which essentially means that, right? Is shifted horizontally to the left h units. And there you go. Okay, so that's the end of this video. Next video is a one problem video. Gonna kind of put it all together. All right. Okay, so stay tuned.